me great pleasure to introduce Rahul Datta to all of you. Uh, to keep things very brief, let me tell you that Rahul has been in the business of ML ops, AI productization for almost 10 years now. He started off his career from TCS as a systems engineer, and currently he's a CTO. He has already been a CTO of a and founder of a healthcare startup in AI. He's currently the CTO of Stealth Startup, which looks at anonymized data set for small language models and AI agents. Uh, his resume is pretty big, but what I can assure you is that whatever Rahul is going to do over the next 4 to 5 weeks will be covering the basic terrain of MLOps, AI agents, etc. That is currently in production systems, and it will be contextualized based on the software engineering the techniques and processes that you have already seen in the course. So, without much ado, let me hand it over to Rahul. Rahul, it's great to see you here, and I hope you have a productive session over the next 4 to 5 weeks. I think today you are starting off with the ML ops
Yep.
part of it.
Yep.
Okay, perfect. So the floor is completely transferred to you, Rahul. Please go ahead. Yeah.
Thank you, Jacob, for the nice introduction. I haven't heard nice introduction for a long time, but it's really nice. Cool, guys. My name is Rahul. As Jacob told, I'm actually from Kolkata, so probably you will hear lots of Bengali accent from me. But for a long time, when I was doing work in India, I was working from Bangalore. So if anyone asks me from outside where are you from, normally I do say I'm from Bangalore. And for last couple of 4 and 5 years, I am working from Amsterdam. And I was working with a couple of companies before, like Oracle, Philips, and after that I started my own startup, mainly in the LLM space and healthcare space. And fortunately slash unfortunately, I have been trapped into this AI industry for last 10 years. Scikit-learn was my first model, which I productionized long time back when I was in Oracle. And now I am playing with this LLM model, training, deployment, and everything. So the main intuition of this session and the other sessions also, and that I will take in next month mainly, that what I feel in my production time means when I am working with other colleagues, what's our expectation and what the students have at that moment. So normally we have to take lots of interviews. We do take interviews from Amsterdam, from US, from Indian counterpart also. And we have seen that all are brilliant, means they do have the knowledge of ML and AI, but they don't have the idea how the ML system works in a production scenario. And That's my intuition here. That's the main motivation that I would love to cover here. That what actually we are looking, the industry, startup, everyone is looking from you guys. That you should know how the machine learning model has been trained, how the machine learning model has been deployed in production. If it is deployed in production, how will you take care? So I know in an hour I can't give you everything, but I will give you some notes. I will give you some points, what I have experienced in the last 10 years in this area. And then you guys can research on it and you guys can learn about it. I don't want to be a part of a monologue session, so it will be a little bit of boring. So I want that if anyone has any type of question, stupid question, brilliant question, anything, every question is a brilliant question. So feel free to ask me. Just raise your hand uh, in the middle of the slide. I am happy to give you the answer. Um, that's it. So I think we can start. So I haven't made like lots of slides. I just make like a couple of slides here. Where is my yeah? I make like a couple of slides, and mainly I will try to draw some diagram in the middle of the class, and I'll try to show it from the actual diagram because I don't believe that slides and everything. A little bit of introduction what MLOps is. When I started my career in 2014, frankly speaking, this MLOps was not the term at that moment. Probably you guys will know that the DevOps term was introduced by Google in 2016, probably 2015, 16 area. MLOps is like a really new. In 2016 and 17, it was expectation that the machine learning guy will do everything. Means he will write the mathematic codes, he will write the optimizer function and everything. At the same time, he will deploy the model also. But people found that the data scientist who knows the mathematics really well, they don't know how the auto scaling works in Kubernetes, and the software engineer also don't understand the data science language. So that's why, and I'm not saying 100% time. Sometimes I have seen some data scientists, they really know how the software engineering works. But normally in the industry, 70% time, the data scientist doesn't have any idea how the model will be consumed by the software engineers. And software engineers don't know about how the code start, how the training architecture and everything. And in 2016-17, there was a term called AI full stack engineer. The main responsibility of AI full stack engineer is that the model we will give them and they will deploy it. But gradually, that term was translated into MLOps. So probably in 2017, 18 to 19, I have seen this term a lot, this MLOps and everywhere. And still now, this MLOps is really important for any organization because, for my experience, I can tell you a secret that everyone is talking about AI, ML, and but 80% times, probably 75%, 80% times, the ML project is in a POC stage. And it is in a POC stage for last 2 years and 3 years. Normally 20% time or 15% time. Probably I'm over exaggerating, but 20% time the models or the projects are pushing to production. I have seen in all over the company. Maybe in startups, the ratio is different. Ratio is like 60-40, but in corporate, the ratio may be like a 85-15. So why? Because data scientists will tell like lots of different models, lots of complicated models. Some of the models will not work in a production. Probably you have heard about a really problem from the Netflix side that Netflix had a competition that who will build the best recommendation algorithm, and some people built it in 2016-17. But the same solution has not been productionized yet because it was like so much expensive. Lots of machine learning problems are expensive, and they need to find the best solution, how the cost will be minimal, and what will be the return on investment. So that's why MLOps plays really great role. If you are a really good MLOps engineer, then you can tell the project manager, you can tell the business that, dude, please productionize this model or productionize this ML solution, and you can do it in lowest amount of money, and the ML model can be productionized. So this is a real problem in the industry now, and that's why all the industry startups, they are always looking for a really brilliant MLOps people. And there are some MLOps solution at that moment, but it is not as celebrated all over the industry. So I will try to tell you that what should be your responsibility if you are a MLOps engineer, and what should be your main philosophy throughout your career. So what should be your main responsibility? So try to understand one thing that in an organization, mainly in an ML organization, there are like a couple of different sub segment. Like one segment is totally controlling the data. They do write all the data engineering code, like all types of pipeline they write. And after that, they are like data analyst people. They are the mathematician. They do have the PhD, and they are like torturing the data, and they know that what type of data will be beneficial for what type of problem. They are like brilliant people, and they build the model. And there are some people like the software engineers that they are handling the all the microservice. And this is like a totally high level view in 30,000 level bit view. So MLOps engineer understands both the language from a data scientist. They know all the layers of the machine learning model. They do know how the machine learning model has been built, how the feature has been selected and everything. And at the same time, they do know how the machine learning model has been Dockerized, how the machine learning model has been encapsulated, how the model will be consumed through an API. Because at the end of the day, the end customer will not be your customer if you are a MLOps engineer. Normally, the software engineers, they will consume your data, they will consume your API. So the software engineers will be the main customer for any MLOps team. At the same time, the data scientist also, because data scientist will give the model. You do need to productionize the model, and the uh, software engineering team will use the model. Yeah, you should have a proper connection with the data engineering team also, but the software engineers of your companies, they will be your main consumer. That should be your main responsibility, that you have to understand both the parties. And these parties are normally anti. If they are saying white, they will say the black. So you have to be in the middle. You have to be evangelize the best practice in both the parties, and you have to build the product in between. Normally in MLOps, we do practice like 3V everywhere, like a big data. There is like lots of Vs in MLOps also. We normally do have like a 3Vs. We call it like a version, vastness, and velocity. Versioning in the sense that every day new data has been generated in production. There are like spans of data. No, when I was working with organization in Elsevier, they did generate like uh, around like a 500 GBs or 600 GBs data every day. So and all the data are going to different models. So you have to keep a proper bookkeeping for that data. So data should be properly versioned. Like today's date is like around 15 November. So the today's data should be versioned as like a 15/11 2024 V1 or something. Why it is so important? Because in a continuous learning process, today's data will be responsible to build another model, and this model API will be defined. So everywhere it should maintain a same name. Like if the data version name is like ABC, the model name should be also ABC, and the API which the model is generating, that API name also should be ABC. And and this practice is really important, or else you will lose the uh, trackability of different data sets. So we have to maintain a proper versioning of it. Second is like robustness. Obviously, we're dealing with uh, fair amount of data. Means sometimes you do need to build the model where the data size is around 1 TB, 500 GB. So that type of data you do need to handle. And as an MLOps engineer, that is your main responsibility, is that you have to build the infrastructure where that 500 GB or that much data will be used to build the model. Because data scientist will just give you the algorithm. You do need to provide the architecture or the infrastructure where you can handle that much data where the model will be trained. And the third part is called the velocity. So fortunately and unfortunately, the data scientist has not any test cases where they can understand that the model is doing good, model is bad. Yeah, they do have the validation set and test set, but it is not like a productionized tested, right? Means in software engineering, normally 1 + 1 = 2. So if you write a logic like addition logic where you are doing this addition 1 + 1 = 2, you do have the test case which will covering that function. But in data science, this finiteness is not there. So in any organization, it is expected that when data scientist is building a new model or any innovated a new idea of like he changed here and there the parameters. They just build the model, and the model will be sent to the production for like 0.001% of user. Data scientists will look that what is the performance of that new model. If it is good, then normally they will increase the ratio. If it's not good, they will just fall back. It will be rolled back to the source. So that's why we do need to build that type of pipeline or that types of infrastructure where just data scientists will get more freedom. He can play with different types of models. So that's a 3V policy we have to maintain in any types of MLOps project. I will go all the section of MLOps that normally we do follow, but till that point, any question, just feel free to ask, or else just I will talk. No question?
Anybody having a question at this moment? Please feel free to raise your hand.
I hope no. Good. Um, then yeah. So MLOps has like different section. Like first, you need to collect the data properly. Then you need to analyze the data properly. Uh, Probably I have created the slide twice. And then the model should be trained. Then the model will be deployed, and what type of framework we'll use. So I'll start one by one. So the data collection part. So normally, what's happening in a production is that there are like a different pipelines in production. Like there are like a Kafka pipelines. Can I write here? Yeah. They are like Kafka pipelines, they are like a SQL database, they are like no SQL database. So when you're working in a recommendation project, you do need to take care with lots of NoSQL database also. So um, these type of databases, you will have like lots of data. And every day they are generating around millions of rows sometimes. So, and when you train the model, you need to understand that what will be your span, means how much data you will need it. So in this data collection strategy, you do need to take a decision with a talk with the data scientist that we do need like a last 1 month of data. And you have to do the analysis that like 1 month, 2 months, quarter, and then you do need to take the decision. And according to the decision, you can put this data in a S3 or any type of storage. Uh, I can't write here. Otherwise, okay, this is black. Okay, so any type of storage you can put the data like that the last 1 month data, and when you are keeping the data in any type of data storage, again you need to follow the versioning policy. So there are a couple of frameworks that will do that job. Most of the famous framework is like DVC. We call it like a data version control. It is like open source libraries. We do use a lot in the MLOps part. So it is mainly used to provide the data versioning. So suppose like, and it is like if you know Git, it will be super easier. And so the main concept is that suppose you have add this cats and dogs folder where you have your preliminary data, and then you new data. You got the new data and just you need to push the data like a DVC push or something. And you do have the old data, and at the same time you have the new data. And whatever you need to pull, just with the ID, you can just pull the data, and the data will be stored in a your pipeline. Um, the best case of using DVC. It is really useful. The MLOps community is using it, but unfortunately, the documentation is not super good. So that's why for last 1 year we do use a new tool called Haystack. It's really fast, really faster than DVC, built on Rust, and really superly useful. Adding a new data source, tracking a new data source, versioning, it is really easier than DVC. So for last 1 year, we are started using this new product called Haystack. So in this data collection part, uh, we are just handling that part only. That integration with different data source, and then we are keeping the proper data versioning that for like today's data, the data versioning will be defined like whatever the data name, like a cats and dogs version A. If it's yesterday's data, like cats and dogs version B. The main idea is that whatever the data version will be, the same data will go to the pipeline, the MLOps pipeline, and when the model will be generated, the model will have the same suffix that the model ABC underscore cats and dogs version A, and the API versioning also will be changed with the same name. So that's why it is like so much important for providing a better versioning. For the pipeline, normally it is depend on the frameworks, that which framework we will choose. Like normally we use Qflow, we use ML for different MLOps framework is there. I will talk about this later. And this type of frameworks will have different integration strategy. And it is also depend on your data engineering team, that what data engineering pipeline they are using. If they are using Kafka, then you do need to integrate the MLOps pipeline in a different way. If they are using normal SQL or NoSQL database, the integration strategy is different. If you are just directly reading the data frame, pandas data frame, Parquet data frame, then the integration strategy also will be defined. So I'm not going into totally detail, but it is depend on the which framework you will select. And if you go, suppose you have selected Qflow, if you go to the Qflow site, in the documentation, it has been written that how you will select the uh, Kafka integration, how you select the CSV integration, Parquet integration, Pandas integration, NoSQL, SQL, everything. Any question about the data collection part? Feel free to ask.
Rahul, I have a question.
Yeah.
Hope I can ask. So you talked about, I mean, I do understand the value of frameworks and in a production system. So one
Yeah.
question is, what is the size of the community that supports these frameworks? For example, you said the DVC is a
Yeah.
open open framework. And typically in
Yeah.
software engineering, one of the things that we stress is on contribution to open source. So, for example,
Yeah.
scikit-learn is a fantastic example of it. So,
Yeah.
could you just, I mean, if you are to look at frameworks in terms of support from community, how would you rate these frameworks? What
Yeah.
all would be your most preferred ones?
Yeah. Really good question. So normally we do follow, we are part of different communities. So there's a really cool community called MLOps community. So they do have like a Slack channels where like 10,000, 12,000 members are there. We do talk like which is the best tool for like data versioning, and we do like sometimes take a decision that this is the best tool at that moment. Other than that, we normally see that what type of pull request issues that guys are handling. Haystack, we found it from Hugging Face. There is a really because Hugging Face probably recently bought the Disney. So we knew Haystack from the Hugging Face community, and that is really cool. And lots of people are using it at that moment. Yeah, so different sources you need to see to grab which is the best tool at that moment for your work.
Yeah. Thanks. I mean, I just wanted to just know which all are the more popular frameworks, because something that I've seen in production systems is the more popular ones are being adopted more rather
Yeah,
than, and even though it may not be the ideal one across, I mean, they
yeah,
just
yeah,
take it as is, right?
yeah. Yeah, sometimes yeah, we are blinded, we are fooled. But mainly the community, if you go to the community, you will have the best answer. The community people will torture the framework, and you will have the what's the pros and what is the cons about that part.
Sure. Thanks, Rahul. Anyone else
Cool.
having questions? I mean, this would be a much more thing if students also ask questions.
Yeah, yeah,
Like Rahul said, no question is a bad question. Every
yeah.
question is a brilliant question, and the more simpler. I mean, if this talk is going over your head, you can ask even basic fundamental questions. What is Git? Even that is a very good question if you ask me.
No question, guys. I think no question. Then we can go to the next slide. If it is like too much information, then you guys can tell me that it is. Then I can I can tell you in a more simple way. If anyone have any issue to understanding the concept, is it good or like I should go more deep or I can?
I
Okay.
okay. Personally speaking, it is going just great. You could go deeper as well if you want, but
Okay,
I don't think everyone has the same level here. So some people might feel it's a bit difficult as well.
okay. So let me know, guys. Means then I will not go that much detail. When normally I do speak a lot.
Okay, others
So
are also saying it's
uh,
good on the chat.
okay,
Can I?
cool, cool, cool.
Hi,
Yeah,
hi. This is Kaushik. Just a quick question. Maybe
yeah.
maybe I'll start with the silly question of the
Okay.
day. It's so what I just wanted to know the kind of division of responsibility between the data science scientists and the ML ops. As in, where does one end and where does the other start, and how does that kind of seamlessly transition? Like where does, for example, model building or the analysis framework, I guess all that sits with the data scientist. Is it as clearly demarcated, or is it an evolving field? I just wanted to get a sense of where MLOps sits in the whole scheme of things.
Frankly speaking, it's not. It's not like it directly. I cannot say that this is like totally data science responsibility or that is totally MLOps responsibility. Normally, I use a line that data scientists write the code in a Jupyter notebook. They don't use any other editor, any other code base. Where MLOps team main responsibility is that translating that Jupyter notebooks into production level API. What I have seen all over the organization that data scientists just build the model, and they will just provide, and this model will not be used in production also. They will provide the framework, or they not a framework is the correct language, the algorithm they will provide the hyperparameters and everything. MLOps team will take this thing and they will try to transfer it into the pipeline. Data scientists and MLOps team really work together because the first iteration will not be successful because when the model will be deployed in a production, 90% time the model fails. So they need to sit with data scientists, they need to change some defined hyperparameters, and the model and the pipeline will take care that hyperparameter changing, and then the ultimate model will be deployed in a production. So it is not totally defined, but data scientists more responsible on that side, on the algorithm side, and the MLOps is more into the software side.
Got it. So is it fair to assume, or rather think that, say, let's say somebody who is already in a software development career, right? Who is already a software engineer, or somebody who's working the software
Yeah,
deployment side and so on.
yeah,
MLOps is a closer
yeah, yeah,
area for them to move to than data science, right? I mean, data
yeah,
science is
yeah,
probably one leap higher, I guess.
yeah. So I would say that promotion, I think everyone can target it for because data. If I run a company, I do have a different expectation for a data scientist, and MLOps is really good because MLOps then they know the software engineering part also. They know how the cloud works. That is the main responsibility for the MLOps side, and they should also know how the data scientist works. So software engineers will really get point. Means they can be the first level.
Okay, great. Thank you. Thank you so much.
Awesome. We do have some question on the chat. I feel that is any questions in the chat, guys?
Yes, there is one. Can you just check that? We talked about how
It
data
don't
set
have
is.
data, just don't have a test case in the software engineering field. How do you then test time and models in the project? I will come back on that point later when I'll talk about the deployment part. Okay, Sakit.
Sir, how we can differentiate data engineering team and MLOps team?
Okay, so data engineering will have different responsibilities. Normal data engineering, what they do, like they will write the data pipeline. So that is a totally different part. What is a data pipeline? So um, uh, suppose like what's the best app at that moment? Swiggy, Zomato.
Yes.
I think more Swiggy users than Zomato.
Okay, then Swiggy. Okay, then let's go for Swiggy. So, suppose like where Swiggy use the machine learning model, I think lots of the case I am taking like the recommendation. When you open the Swiggy, they will provide you the top picks. So they obviously use the recommendation algorithm to provide the which like butter paneer will be there or the biryani will be there. So which one will be there and which images will be there. That is also created by the machine learning algorithm. So when they are building this recommendation model, how the Swiggy team got the data for the recommendation model. For recommendation model, they need the user activities, right? So the user, so Swiggy has like how many downloads all over the India? Probably, I think 10 lakhs minimum. 10 lakhs people are providing every time they define different activities. So every millisecond or every second, the data has been generated. Where the data is going, probably Google BigQuery or something. So these data engineers are building this robust pipeline where all the data from all over the world has been gathered, and it is gathered in some data set. It is going to any other database, and in most fault tolerant way, so the data will not be missed or the data will not be failed. So that is the data engineer's main responsibility. The famous like a cap theorem, there should be like the data servers will be available enough, the journey should be consistent enough, the servers will be partitioned enough, the data pipeline and the servers where the data has been saved. So that is the data engineer's main responsibility. So data engineers and MLOps engineers, they are really good friends because the data, what data they are generating, it is the input for the MLOps team. The data, again, this is coming for the data collection part. That data is versioned. And so this is the input part for the MLOps side. At the same time, when the ML model has been deployed in a production, then the data engineers sometimes they do have the API. So they do have the API call, which call is consumed by the MLOps. So this is two different subjects, but they are two adjacent, this MLOps team and data engineer team. Is it good or I should tell more? Am I audible?
Yes,
I
sir.
think that
Yes, you're audible.
Swiggy example actually nailed it, I guess. If anyone is
Okay,
having, yeah, yeah, I see hands ups from many people.
cool,
Good one,
awesome.
Rahul. Yeah.
So let me know if when I'm giving like theoretical knowledge, if you want to understand from the practical example, that's also I can give you. Plus, just let me know. Vocal up, yeah. So after the data collection part, then the second part is coming. It is a data analysis part. Frankly speaking, MLOps engineer don't take the responsibility for the data analysis part, but normally this logic is coming from the data scientist side. What is data analysis part? Like what I told, when the data is coming from the data engineering side, like for the Swiggy example, like lots recommendation data, you need like lots of user activities. And some of the user activities are like zero. They're like the data is not always good in a base scenario. Your data frame is solid. You have all the data points everywhere. But in a practical scenario, uh, it is mess. When the data is coming, the row name, column name is different data frame has a different data. So we do need to write lots of the logic to generalize all the flows. And it's depend on the data engineering side. It depends on the data scientist. Sometimes the data is invalid. Sometimes data, there are like 11 level, 13th level is coming. So you do need to do lots of hard-coded logic. You do need to put there. Sometimes people translate the data into different features. Feature engineering also there. So all work has been covered here. If you are building a classification types of thing, classification type of model, like you do need to select like the cats and dogs picture. The cat's picture is like 90% time in the incoming data set, and the dog picture is 10%. So obviously your model will be biased. So you need to take also data imbalance problem. Then data offensive problem, like you are building some image recognition website where like all the white man's picture are there. So the model obviously they can understand brown, or they can't understand a black man. It actually happened in Europe. There was a in a shopping mall. There was a image recognition camera that only detects the white man, and that doesn't detect any brown or any black. Then we understood that the model trained only on the white man's image. So lots of the things: data offense, data spamming, pornography, nudity, different types of pictures are there. So you do need to check it, that data, when you are doing the text analysis. You do need to handle that people are using it for the spam purpose or not. They are putting some slangs or not. So lots of types of analysis, this type of hard-coded analysis has been handled here in this data analysis part. Then the feature engineering. For the feature engineering, probably you guys know that when there are like 200 dimensions, 200 dimensions in the sense is like um, mm, uh, what can I say? For the recommendation algorithm, just I said for the Swiggy, you have the user activity matrix. At the same time, so any idea how the recommendation normally works? Anyone? So I'm giving like a really brief 5 minutes talk how the recommendation system works. So normally when you have the user activity for like from the lots of users, we will try to build and model an embedding model that where we will see that how the user one is responding with the item one, how the user two is responding to the item 10. So there is embedding vectors have been developed on that part. At the same time, we are also developing a different embedding clustering on the recipe side, like biryani, chicken biryani, prawn biryani, mutton biryani. They are in the same cluster. At the same time, paneer, blah blah blah, is the same cluster. Rotis, naans are in different cluster. So that's happening from the recipe embedding. At the same time, there is also user embedding. Like where are you from? Like I am from Bengal. Then if you are from Mumbai, then the Bengali people are eat a food a different way. Telugu people will consume a food a different way. So there's a user embedding, and then like other embedding also. Like YouTube has around probably 100 or 200 different types of clusters when you are providing that recommendation on your page. So all the embeddings will be ingested into XGBoost or that type of model, basic model, and that XGBoost will give you the best 100 or top 50 recipes or top 50 videos, and then different machine learning model will work that the position of that model. So long story short, so when you are building this embedding, you have like lots of columns, like 200, 300 columns. And one column is saying like age, one column saying is like what's your mother tongue, one column is saying like you're vegetarian, non-vegetarian. So different types of columns are there. And sometimes you don't need that many information for a model. So through the feature engineering, you can do it. There are like different types of techniques where you can see that which features are more important. And then there also you are using different types of codes, different types of logic to take care that which features are more responsible to change the model performance. There are like different techniques. So in a machine learning, we don't do this thing in a production directly. Whenever we get the data, we build the features and we put it in a feature store. Like a database, we do have like a feature store. Normally, we do use all over the world a framework which we called, I written it down somewhere, is called Feast Dev, which is generated by Uber. Uber first developed it to store their time series data, but it is now used all over the world to store all the features in the feature engineering. This is really important. Why? Because think about this scenario, like in a training time, you have written your code, featured code, and your input data is coming, and you are building the features from here, and you are putting it on the featured store here, like Feast Dev. Your model has been trained. Your model has been deployed in a production. You have the API. So when your model will be called at the same time, model should be called with the feature output, right? It will not, if you call with this input, the model will not respond anything because model will not understand whatever you are talking here. So you have to provide the input which this dabba, this box is providing as output. It is called is famous problem in the machine learning world. We call it like a training serving skew. Means whatever your algorithm logic will be here, that logic should be same in the production in the serving time also. So that's why the feature engineering code and keeping the feature engineering code plays a really great role. Yeah. So whatever database you are using, normally, if you're using Feast normally handle that part, that you can store the code, the logic here. So at the deployment time, you can tell that the store, they need to use that code you need to use to translate the data into like 101010 that features will be called to the model to grab the output. Yeah, that's it for the data analysis part. Lots of boring part, but yeah, that is really important before pushing the data into production. Any question?
Yeah, hi Rahul, Lalit this side.
Yeah. Hi, Lalit.
Hi. Thanks a lot again for such a informative talk. So all these things, whatever you are explaining, so they are
Yeah.
happening through a pipeline?
They're happening through a pipeline. Whenever you are developing everything, so whatever I'm saying here, it is like a block of the pipeline. And at the end of the day, you need to build the rail of these blocks, and then the pipeline will be executed.
Okay. So till now, what I have understood that basically the data scientist who is there, he is writing the algorithm
Yeah.
and he's finding the best model. And
Yeah.
thereafter, once it comes to the production stage, okay, that might not work, like you said, like 90% of the times.
Yeah.
And where like, the data is being stored, that is the work of the data engineers, and the ML ops is the one link which is between the model which has been created by the data scientist, and
Yeah.
now the churning the data, and these pipelines, they have been given in the code given by the data scientist, but you are working more on that, how to get the data from the data store, whatever you're using, BigQuery or something, and it is
Yeah.
happening through a pipeline.
Yeah, it is happening through a pipeline. So yeah, data scientists will give you normally the feature that this thing is responsible. Then probably both will work together and make the code, and that code will be ingested in the pipeline.
Okay, thank you.
No worries. Any other question, guys? Then I will go to the next section, the main important section, the model training. I think then we're good.
Hello, sir.
Yeah, hi.
Harshit,
Hi,
sir.
hi, hi. Hi.
Yeah.
My name is Rahul, not sir.
Oh, hi, Rahul.
Hi.
So, Rahul, these are fine. So, actually, we want to implement these in our office and our work. So, can you,
Yeah.
side by side, tell us some tools also which are available, which are
Yeah,
really
I'll
working?
come back. I will come back the later point. In the 8th slide, I have written it down. whatever
Oh,
tool is really famous. But I'll tell you every point here. Okay.
seriously, because I asked ChatGPT, it will give some answers, but I need real answers.
Cool. I'll try to provide better answer than ChatGPT.
Okay. Thanks, Rahul.
Cool, no worries. Cool. I think then we can go to the most important section, which is like a model training, where the MLOps plays a really great role. So look, there are like two types of model in this world. One is like a CPU heavy model, like scikit-learn, my first model, then logistic regression, XGBoost model. They are all CPU heavy process. They don't need GPU a lot. And they really still now, for some of the use cases, they are really better than the other transformer, blah, 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 that type of models. You just need to select a proper use case for that. For like a time series type of cases where loss regression and XGBoost model, they're superior than the other models. And I do love this type of models because in a production, it is really cheap. The XGBoost model, loss regression model, scikit-learn model, just you need a proper data, you do need a proper feature, and this model will overperform. And there are other types of model, which is like a deep learning based model. They are transformer based model. Previously, there was like LSTM, RNN, CNN, this type of models, and now transformer takes all the place. So transformer based model, the best is GPU. GPU will provide the best inference, and at the same time, the GPU will provide the best training infrastructure. So um, in MLOps engineer, we normally face like a couple of problems. And the first problem is that sometimes there are like lots of data, like GBs of data. And you can't put all the data, like if you have like a 40 GB data, you can't put all the data in a single what's called pod, because if you take the your always intention will not be that I will take the 192 GB RAM, that machine, and 192 GB GPU, because always you will not get that machine. You will have to means that is obviously costly, and sometimes the spot instances you can't take the dedicated instances, and the spot instances you will not get it always. So the infrastructure guy, we always prefer that we will take the low instances, like where you will have like a 32 GB RAM or 64 GB RAM. If you have the highest data, then you will split the data. Suppose 8 GB data will go to the CPU 1, second 8 GB will go to the CPU 2, third 8 GB will go to the CPU 3. Now the main problem is that how the training will go, because we all know the basic of the model training is a gradient thing, right? It's how the models are learning. Like all remember that curve that y equal to mx plus b, when you were doing some mistake, the y delta, then the y has been reduced, the y has been minimized, and that's how the model learned. And if the data has been divided into multiple CPUs, how the model learn together. That is a famous problem in this machine learning world. And that's why the new concept called distributed training. Distributed normally came into 3-4 years back. There's a really cool framework. And this is like a really cool engineering problem people have solved. For this scenario, we do use a framework called Ray. We do use a lot Ray in a production when we need to train a model with a large amount of data. Ray is really cool when you have like lots of data and you do need to use distributed training. If you want to understand how distributed training works in really great way, I would suggest go to this Ray GitHub and there's a link.
Did you say distributed training?
Yeah.
Okay, thanks.
Yeah, so go to this website, go to their documentation. you will have the basic idea how the distributed training works. There is another framework which I love in the last 3-4 years. It's called ALPA. This one. It is also I found really cool for the distributed training. There are also lots of research is happening how you can do the distributed training in more optimal way. I can't say that the distributed training always successful. 90% time, 85% time it will works, and 15% time it will not work because you can control a couple of things. The networks, the server should be in a same location, same region, and there are lots of network problem. And for the network issue, sometimes the distributed training has not been happening because everything has been happening in a milliseconds. When the other CPU one is learning, that learning should go through the CPU 2, so that all the learning should happen all together. So that's why the network should be solid, but sometimes the CPU 1 is US East 1 zone and CPU 2 is US West 1 zone. It's really creating a problem. And that's why there's another concept called federated learning, federated training. And there is a really cool framework called flower.dev, which is really famous for this federated federated training concept. So the main idea is that if your one GPU is like US, another GPU is India, another GPU is Singapore, another GPU is Australia, multi-region. But if you use that framework, this framework will try to reduce the workload and try to reduce the problems what distributed trainings are providing. There's another concept called 3D parallelism. It is really a large topic. I don't want to cover this 3D parallelism, but there is a really cool repo on it. I would suggest, again, I am suggesting because if you can, the documentation is really good here. This Megatron LM. If you can go there, you can totally understand how the 3D parallelism works. This is really important because for all the LLM model, not the LLM model, like if you have like a really large database, like normal LLM model, large model, language model, sorry, they use this framework Megatron LM to do the 3D parallelism. The last model, Llama 3, this LLM, they used probably Llama 4D parallelism, and I found it on the research paper. They're also another cool thing you guys can learn. So long story short, sorry guys, I can't get so much detail and this for the time. But whenever you have a time, just read about these three things: distributed training, 3D parallelism, and 4D parallelism. Frankly speaking, I haven't used 4D parallelism in production because it has been invented last year. In the Llama paper, we have found 4D parallelism. 3D parallelism we have used a couple of times when we have like a large database, 80 GB and 120 GB database, and we have to train this model daily. We had to use 3D parallelism, and we used this Megatron, and we used this distributed training, Ray, Alpha in a backend to provide the training infrastructure. And that's how this MLOps can play a great role. That's I was talking about in the first slide, why the machine learning models, 85% machine learning models are in a POC stage, because when you are trying to push it into production, you will face this problem that you have like 80 GB and 100 GB data you do need to train every day. Because if you build a better model, then this model will provide a better interaction with the users. Try to understand one thing. If you have like 100 GB of data and you build a model, this model is in production. If you don't train the model daily, then this model will provide some rubbish result in a production. Ultimately, your profit and revenue go down if you are not training this model daily. So training model is required. And for better training, for better infrastructure, we need to adopt this distributed training philosophy, 3D parallelism philosophy, so that we can provide the best infrastructure and best cost to the software engineering team or to the business. Yeah, that's it for the model training part. I know it is really I haven't I haven't told all that thing in detail, but I would suggest just know this thing and try to read as much as you can. Any question, guys?
Rahul, if you,
Yeah.
one suggestion, once the session ends, if you could share the links that you have
Cool.
just described. I know you have
Yeah.
put it separately. We
Yeah.
will add that as a description to the live stream session so that students can actually go and check and learn more.
Cool. Awesome. I don't do that part.
Yeah.
And
Sure. Thanks, Rahul.
yeah. No.
Also, just a quick addition. Also, if you're sharing
Yeah.
the links, if there are relevant papers, if you could share them as well, those can also be linked in the description.
I don't read normally the research papers, but normally like Megatron, they do have their own research paper. You can find it here. All the GitHub
Sure.
links, you can find it out there. Okay.
Sure. Thank you. Yeah.
Cool. Awesome. Now there is a another part called model analysis or model performance that will come back later. But after that, guys, it is probably 10, so probably I need another 20 minutes. Is it a problem or is it good?
Yeah, I think it is okay. I
It's
think
good. Yeah.
people are
It's
not
good?
logging out, which means people actually want to
Okay.
listen to it. Yeah.
Cool. Awesome.
Yeah.
And then we can talk about the model deployment part, which is like really important because you have trained the model. Now it should go to the production site. So try to understand how the model deployment works. So you have the model, which is like if it is like a small language model around 3 GB or 4 GB model, if it's like a large language model like a Llama, medium size, I forgot the size, for 21B or something, which is like around 28 GB or 32 GB. And so a single GPU can't handle it. So sometimes you do need like multi-GPU cluster, or sometimes you need a single GPU cluster. For simplicity, for that presentation, I am going to a single GPU things where your model will be deployed on a single GPU. You have like a small language model. So when you have the language model, we have little bit of test cases what we run on that model. We got the result. When you are happy with the result, the data scientists are happy, you are happy with the result, you normally push to the containerization part. So what is containerization part? So there are like two types of containerization is happening. One is like soft level containerization, and another is like a hardware level containerization. We do use different types of hardware in production. If it is like a CPU, like a XGBoost or that type of model, normal CPU-based model works fine. You don't need any containerization. But if you are using that text-based model, like or vision-based model, then you need to use a transformer, right? And then the containerization come into picture because you do need to use the GPUs or the other hardwares. Other hardware, what I'm saying, there are a couple of hardwares like Google has their TPUs, AWS has their inferentia. They do have a defined chip. So normally the TPU pricing and inferentia pricing is less than the GPU pricing. These chips has a defined quantization mechanism. So if you are using, so I am starting with the first one. So suppose if you're using the GPU one, normally the NVIDIA GPU one, normally we do like TensorRT quantization. So through the TensorRT quantization, what is the main idea of quantization? So the main idea of quantization is that it will reduce the model size. The main advantage for reducing the model size is that it will take less space on the RAM of the deployment machine. If it takes the less space, then the latency will be higher. At the same time, the throughput will be higher. The cost will be less. Cost, when I'm saying that the cost per API would be really less. But there is a but. And the performance may be decreased by 2% or 3%. depending on your quantization parameters, depending on the quantization hardware. But when we are pushing a large model, like a transformer based, when I'm saying the large model, I'm saying the transformer model, because to me the small models are XGBoost and scikit-learn model. The large models are the transformer based model. Large model is the LLM model. So when you are pushing the large model into production, quantization is necessary, because without quantization, the transformer model takes around 1 second, 1.5 second in production for a single request. We can't tolerate that much latency in a production. We do need a latency under 20 millisecond or 20 or 70 millisecond, 50 millisecond. So that's why we do need to push through the quantization layer. Normally, there is a open source quantization which we called Onyx. That one. So normally, every model, like PyTorch model, TensorFlow model, every model can be translated into Onyx format, and this Onyx can be used any hardwares. Lots of people will use that format for the best choice because it is interoperable and any type of hardware can support. But if you know that a model will be deployed into NVIDIA GPUs only, then the best way for the quantization is TensorRT. Not LLM, only TensorRT. So this TensorRT normally we do as a quantization mechanism. And we have achieved really around 90%, 80% improvement through these quantizations. So if people are using NVIDIA, I would suggest to use the NVIDIA TensorRT quantization. If people are using AWS Inferentia, then Neuron SDK, AWS, which is preferable. If people are using Inferentia on the production, then they can quantize their model through that framework and they can push it to the production. That is the quantization. So now I came into the last part, is called server. I have seen 70% or 75% time people use only a fast API based server. I don't have any problem with it, but as experienced MLOps developer, I don't use fast API in a production. There are lots of framework which has been built only for the machine learning model deployment. The really famous one is .serve, which is coming from the PyTorch framework. The serve or .serve, really cool community support and really stable product. .serve is really useful when you want to deploy your model on a GPU and you want to deploy a transformer-based model into production. I recently love with another framework that I use a lot, which is called Triton Inference Server, which is coming from the NVIDIA architecture. If you use TensorRT for a quantization, then Triton Inference Server should be the first choice. The binding is like so good. The latency and everything will be really low. What we have achieved through the TensorRT quantization and Triton Inference Server. So for all the scenario, I should suggest go for .serve if you're using PyTorch model in a production. If you are using transformer-based model and you are pushing all the you are going through the quantizations, then Triton should be the first choice for the productions. So, and if you use TensorFlow, then .serve and Triton, or Triton can help you out, but .serve will not help you out. If you're using TensorFlow, then there is a TensorFlow serving that people use to productionize TensorFlow model into production. So this is the best three things. And the other thing I have used a lot that is called Sheldon ML server. If you have like a XGBoost or scikit-learn, that type of small models, then ML server is really playing a great role. So that 4 servers I can talk about. First one is the .serve. Second one is the Triton Inference Server. TensorFlow serving for the TensorFlow based model, and the fourth one is a Sheldon ML server for small models, like XGBoost, scikit-learn, that type of models. Then I want to talk about another cool framework, which we do use a lot. Why? Which name is Keserve, Keserve. Keserve is coming from the Kubernetes framework. The main idea of Keserve is that this picture mainly. When you are deploying this model into production, normally how you are deploying you have the model, you have selected the server, then you have downloaded the Docker, and on the Docker you have encapsulated everything. So the Docker input output is like a Docker will provide a API, this 8080 port, and you do need to hit that API, and you will get the result. And this Dockers should be deployable any other Kubernetes cluster, right? So if it is like there are lots of users, you do need to deploy on a Kubernetes cluster. You can deploy directly on the Kubernetes, but there will be lots of problems you may face because, and that's why Kserve will play as a wrapper between the Kserve and serving the model. Kserve is like an open source community which is coming from the Kubernetes framework. They built like a Kubeflow and everything. So Kserve is mainly used for serving the machine learning model servers. I am using this Kserve for last 4 or 5 years, and it's really cool. Lots of big organizations like AWS, Bloomberg, lots of big companies, they are using Kserve for their day-to-day work in a production. And lots of the big companies, they have, I don't want to name it now because of this. Lots of big companies, they build their framework on Kserve. But it's really good when you are building your tech stack or your system directly on Kserve. Really easy to start the Kserve, and it will provide lots of the things what a machine learning engineer should need. It will provide like a multi-model serving, then whatever I told, like the feature engineering, it will just encapsulate this thing, and it's really easy to use. Like if you want to use a feast, just you need to change the YML here, and you can directly write it. Model storage, define like S3 Azure, everything. It will support model monitoring, and that's why I told you that I will talk that. I will tell that part later. When the model has been deployed into production, normally we do need to see two things. There are like two types of metrics it is generating. One is like a software engineering related things, like there are lots of 500 errors happening or not. What is the GPU has been allocated? What is the memory has been allocated? Do need to see this part. At the same time, we do need to see that how the model has been performing with the data set. So for the first part, like for the software engineering part, we do have like lots of system. We do have like a New Relic. We do have like a Prometheus open source thing, where you will Grafana, where you will have all the data dashboard and everything. That Grafana also connected to the Slack. So if your GPU has like 90% or 95% allocation, you will get the alert or anything on the Slack. That's already been there. But there is also data science team that you do need to see that like you have built the cats and dogs classification model, and all whatever the pictures it's getting, every time it is providing the cat's picture. So the model is really biased with cats. So that type of thing, you do need to do lots of data analysis part. That thing also you can add with the Kserve. And the best part, and the other things like you all know about the REST API, right? But in a production, we don't use REST API for the MLOps part because REST API is really expensive. When you have like millions of call, you need to handle everything. REST API is really good till that point your connection is not stable, because REST API is really good for the debugging. When you have like millions of calls, we normally do use the gRPC, which has been invented by Google. gRPC normally like sometimes 30% or 40% less expensive, means your latency will be increased by 20% or 30% if you use gRPC over REST API. So all types of support like a gRPC support and everything, auto scaling, rollout strategy, Canary, everything Kserve will support, and you don't need to write the most complicated code. So it will encapsulate everything. So I really suggest to use Kserve in a production whenever you are building when you are deploying a model into production. And you should guys know about how the Kserve works, and you guys can actually this test that Kserve on your local machine. There is a framework called Minikube that can be installed in your local machine. Minikube is like a smaller version of local Kubernetes. So if you have Minikube on your local machine, you can deploy Kserve on it, and you can play with the really small model. Don't try to face the large models, then your machine would be corrupted. But if you have the small machine, just install Minikube, play with the Kserve, try to understand how the different functionality of Kserve, and it is really useful in a production. If you are writing your CV that you have worked on a Kserve, your CV will be selected. That I can challenge you. Then I am coming to a last part. That is about the framework. I have used a lot Qflow because Qflow is coming from the Kserve community, and Qflow has really great documentation about all the parts. That part I have discussed at the data analysis, model training. Google really use Qflow on their backend. So that's why their code base and everything, their Slack channel, their community is really strong. And if you want to build this Qflow pipeline, you can find it everything, the example notebooks and everything, you can find it on their website. I haven't covered a single thing that is called Katib. Katib is mainly used for the hyperparameter tuning. So suppose if I build a scikit-learn model or any other model you are using lots of hyperparameters, right? So if you want to tune the hyperparameters, then the Katib has been used. So in a Qflow community, there are like lots of different frameworks, different components you guys can use, which will be really beneficial. So I am a little bit of biased to Qflow because Kserve, Qflow, and I am using lots of the open source community which is coming from the Qflow community. Uber has built their own framework called Michelingo. Lots of people are using it and they really love that product. That one. It is open source, and I need to find where is the GitHub link. I'm trying to find it, and then I can send you the link here. Then is Metaflow. Metaflow is sometimes really good when you have like a small model into production. And in a Metaflow, the encapsulation is so high, you don't need to write lots of code. And lots of the team are using Metaflow in a production. It is really easy for the data scientist to build a model and push it to the production. And that's why Netflix built it. There is another tool lots of data scientists use called Flight. That is again open source, and which is really used for the orchestration purpose for all the MLOps work. But if you ask me, I still support this Qflow for the lots of my day-to-day machine learning and MLOps works. Yeah, that's it, guys. Lots of information. It's 10:16. Feel free to ask any type of question. I'm happy to answer.
Hello, Rahul, Harshit again.
Hi, Harshit.
Okay, so my use case is such like I am working in a company,
Yeah.
mostly US based company, and they are using .NET
Oh,
framework. Yeah, it's kind of
unfortunately.
yeah, it's completely US and Microsoft based.
Yeah, yeah,
So they have huge amount of data, and they want me to apply AI things and search bar, all this kind of thing. I'm using
yeah,
Olama and
yeah,
using it as an API on
yeah,
PowerShell and getting data from database and using some kind of script and doing the work. But I
yeah,
don't think like it's a proper way. It's like Jugaad kind of thing. So
yeah.
I need one. Can you suggest some proper framework so that I can integrate AI with .NET? It's like,
Um, AI.NET, I haven't explored a lot, frankly speaking, and the .NET framework. I used .NET last probably 2006 and 7. After that, I haven't used .NET a lot. But in the next class, I will talk about RAG a lot, RAG and LLM serving,
uh,
where I will talk about different types of deployment mechanism, how the LLM models can be deployed, and probably that can help you out.
yeah, sure, Rahul, sure. Yeah.
Awesome. See you in the next class.
Okay. Yes, Rahul. Thank you.
Yeah. No worries. Hi, Pritadeep.
Hi, good evening. Am I audible?
Hi, Guru. Yeah, you're audible.
Yes. Thanks for the session. I have one
No worries.
question and a suggestion or a request
Yeah.
rather. So I'll just go with the question first. It's not directly related to whatever you said here, but I'm just curious. The
Yeah.
AMD ROCm thing, the ROCm framework that they made to compete
Yeah.
with CUDA, is
Yeah.
it still relevant? Is it relevant yet in the industry, or is it still not that useful?
Frankly speaking, I don't want to use NVIDIA, but why I use NVIDIA?
Yeah.
Because the framework is so stable. I think NVIDIA, what they are super successful because they have built a beautiful framework called CUDA.
Right.
And PyTorch and CUDA, they are like the best boyfriend girlfriend. They are seriously super good, really integrated. And if you use like a PyTorch and CUDA and you using Triton inference server, the yes, MLOps engineer, I don't need to take more tension if I use it in a pipeline. AMD, frankly speaking, they have done lots of improvements for their chip, but they haven't built that framework which is really comparable with the CUDA. And they're going for it. I think
So
I don't
they're
need 2 3 years to grab that trust from the AMD side. So I will wait to use AMD in a production.
right. So actually, they have been talking a lot about the ROCm framework and how they plan to compete with CUDA. I was just wondering if it is yet popular in the industry or not. So that is why I asked this question.
In an industry, it has not been popularized yet
Okay.
because lots of the things you will get it like the 3D parallelism, what I had talked about,
Mm-hmm.
the Megatron, the Ray, and everything. Like all other frameworks are really dependent on the NVIDIA ecosystem. And
Yeah.
it's not about like only the deployment side, right? The training side and everything. So you do need to take care of the other parts also. So that's why it will take some time to take in
Got it.
the ecosystem. Yeah.
Got it. Thank you. And my suggestion or a request
Yeah.
for the upcoming sessions, if you could just give a brief overview today itself, what you will be talking about, or at least if you
Okay.
mention the
Okay.
topics.
Okay. So today's topic was a basic topic. My intuition was that people should know how the ML models work in a production. So I wanted to give a brief introduction how the machine learning model has been trained and how it has been deployed. The next class I was thinking to take about on the RAG, which is lots of people are talking about what is RAG actually, retrieval augmented generation, where you shouldn't use RAG, where you should use RAG, and how the LLM models, how this ecosystem is working on. That will be the second class. Third class, I will talk about mainly for the AI agents because I do love the AI agents. I have been using AI agents in my startup for last 6 7 months, and the future is agentic. In next 1 or 2 years, everything, the website, everything will be agent friendly. I do want to talk about these agents, and probably on the fourth class, me, JK, will talk about how the software engineering practice are being changed in this LLM area. How a single engineer can write a full stack app in 7 days using the LLM. So we'll try to provide probably a practical scenario, practical class. Yeah,
Okay. Okay.
that
Got
is
it.
yeah,
Thank you. Thank you. Thanks for the session.
yeah, cool. Yeah, any other question?
Yeah, I think I'll just make sure that before the next question comes, I'll just give a brief overview for all the learners out here. I mean, this is primarily just to give you an overview how we connected with Rahul and what the idea was. So we had ran couple of software engineering projects where we talked about ML use of ML along with software engineering applications, real applications. And last time, I think we actually used the LLM application. I mean, it was like an LLM application that we wanted to test out, and we wanted to see how students are performing when it comes to use of ML in a practical scenario. And we found that there are a lot of places, lot of gaps that needs to be closed. And also, as Prajesh, the course faculty, and I and Arup, three of us have been discussing this multiple times. And I think Arup, yeah, it was almost timely that Arup introduced Rahul to us. And it has been, we had an initial discussion, and something that we want to really tell all the learners over here. We may not do deep dives into many of these topics, but what we are expecting is we'll provide you the initial starting points and some basic overview so that you can take the deep dive and come back to us. I mean, of course, you can come back, use discourse for further discussions or internal groups. But I think what Rahul will cover over the next 4 to 5 sessions, like Rahul rightly said, it's about a basic overview of what is happening on ground when it comes to ML, LLM, agents, and of course, how the practices are changing. I mean, how it is more of individual contributors turning into a larger team with the help of agents. So that's the larger idea that we will be talking about, and also we'll cover the standard software engineering, the standard practices, the agile development, and all those things. We'll try to see how these two, how it is relevant to the software engineering processes as a whole. And yeah, and we will be yeah. So the Friday this time will be completely we will do these deep dives over the next 4 to 5 weeks, and we hope a lot of you will take up these notes and explore further and come back with more questions. I think Rahul also is interested in having dialogues with all of you. Some of the questions were really good, especially on understanding how ML production is coming in. Maybe for the next session, maybe Rahul will talk about real applications and how it actually works in LLMs. I think that hits a lot of them are aligned when you talk actual examples now. So I think today's talk, it was fantastic. I mean, a lot of different new tools, frameworks, whatnot. I mean, it was it was a really I would say it was worth the 1.5 hours. But yeah, I'll open up for students to uh, ask questions. Maybe is it okay if I stop the stream right now, Rahul? Maybe
Yeah,
the
yeah, no
questions,
worries.
the other
Yeah,
questions can be taken offline. Yeah.
yeah, yeah,
Okay.
yeah,
Just give me a couple of minutes. Yeah.
yeah.
Yeah. Others, please feel free to ask questions to Rahul at this moment.
Am I audible?
Yep, you're audible.
Hi, Rahul. Thank you for the
Hi,
session.
hi, hi,
Uh,
hi.
a question that if I want to become an MLOps specialist, so what
Mhm.
are the projects that I could get started with?
I think great question. So so I can share my journey. So previously I was like this lots of organization. I was doing lots of ML works, but when I try to grab the MLOps on my portfolio, I just went to these websites and there's Qflow, Kserve in different websites, and I follow their notebooks. So their documentation is really good. So if you can go to their website, you can learn everything how the system actually works. You can execute this on your local machine. And this Kserve and like Feast and Megatron, they are like open source community. If you can execute this thing on your local machine, you can solve couple of peer. So you can do like little bit of open source contribution, and then you can build like a small demo project, or you can introduce this type of philosophy on your day-to-day life, like wherever you're working or wherever you are studying. And I think if you can write down your your if you write down your whatever you have built through this MLOps on your CV, I think your experience, through your experience, you can grab a MLOps job. That will not be a problem. So for your answer, I think go to that website, Qflow, Kserve, .serve, and try to learn it from their websites and try to build a small project using their tool.
Thank you, Rahul.
Thank you.